Let's get started. I'd like to introduce KYZEN Sales Support Manager, Jody Saultz.
Thanks, Cassie. Thanks for joining today's Tech to Tech. We're going to start off by talking about smart pH employment and electronic screening. But real quick, just understanding pH a little bit. So pH is basically a scale of acidity from 0 to 14. It tells how acidic or alkaline a substance or a solution is. More acidic solutions have a lower pH, higher alkaline have a larger pH or higher number, and then of course 7 neutral being in the middle. So acidic, alkaline, and neutral, they all refer to positions on the scale of a pH ranging from 1 to 14. Acids and alkalines aren't as bad as you would think. Alkaline cleaners are good for oil removals. Acidic cleaners remove rust and scale, and then neutral cleaners do both, but they do have shorter bath lives. If you look at the chart, it's kind of scary to think that battery acid is a 0 and vinegar and some orange juice and grapefruits, those are around the 2 and 3 mark. So they're very acidic, but yet we ingest those. And if you go to the other end of the scale, soapy waters, bleaches, oven cleaners, these are up in 12 and 13 range on the alkalinity side. And I wouldn't, don't ingest those because it's probably not going to kill you, but you will get sick. So as technology evolved, CMs and OEMs moved toward a aqueous-based sprayable cleaning agent. These cleaning agents were perceived to be environmentally friendly. They tended to be high in alkaline, usually above 11. They had short bath lives and terrible compatibility on devices. And they was also very harsh on equipment. If you're familiar with ArmorClean, which was a pH of 11.6, it was a great example of a early aggressive aqueous cleaning solution. So the best pH range, or the best neutral range of cleaning agents are balanced. And what I mean by balanced is the ingredients are usually formulated together so that they provide a high level cleaning activity, very low in toxicity, consistency from the start of the bath all the way through to the end, and acceptable cleaning performance in production conditions. So there's a lot of advantages of staying at pH neutral of 7, but it's my belief that if you go a little bit slightly alkaline, there's a little bit more advantages to being that higher side. Mild alkalinity enables saponification. It's going to result in faster cleaning, less exposure in time and less energy, and better soil load, which enables a longer bath life. Keeping pH in balance will give you the stable compatibility through the entire bath. And you can also add functional additives. They can also be engineered and formulated to enhance inhibition for sensitive metals and coatings. If there's some additives that can't be added or engineered into these formulations to enhance that inhibition, then you're going to get that pH shift, and there is potential cleaning issues, compatibility issues, and corrosion. If you look at the slide, you can see the corrosion happening on the one on the right, and then the board on the left basically is just carrying flux-laden residues. What happens to pH with acid flux? Adding flux to a wash section has potential to lower the pH. And really, there's no potential. It's going to happen. It's just a matter of when. When cleaning PCB in a production environment, acid flux is continuously being added to the wash tank. To avoid this pH shift, using an engineered chemistry that is formulated with these materials and buffering agents to help stabilize the pH, it's going to help with extended and longer, and you're going to achieve longer bath lives as well. So in today's modern cleaning agents, they usually consist of a solvency package and an aqueous package. Solvency to solubilize nonpolars, and then aqueous to dissolve polar soils. There's also functional additives with these, and they consist of defoamers, buffers, corrosion inhibitors, wetting agents, and other minor ingredients to improve compatibility, bath life, and bath loading. There's also a biphase cleaning agent, which is what most CMs and OEMs are using today. There's a solvent phase and an aqueous phase. The solvent phase targeting these nonpolars, and the aqueous phase targeting these polar soils, which allows for this to be sprayed in a spray and air type system without any safety concerns. So they're typically partially soluble in water, and neutral products are less effective on polar soils, and good rinsing requires both the aqueous and the solvent phase to be greatly balanced together to be able to achieve good rinsing. So alkaline solutions, better for cutting these oils, dirts, and greases, and other organic items. Acids are better for cleaning these, or for removing the calcium, rust, and other minerals. And if you think about the pH being below 3, these are also referred to as corrosive. And if you go to the other end of the scale, pH of 11, these are considered caustics. Products with the values between the 6 and the 9, they're found to be within the pH neutral range. Products that excuse me, measure at either end of the scale, these aren't really recommended for cleaning electronics. The solutions that have the pH at the extreme ends, they're going to react a little bit different with these metals. You know, we put solvents in these so they're able to clean flux, but when you go for each end of the scale, you're going to get some kind of negative interaction with these certain plastics, epoxies, coatings, and they're probably not going to be very user friendly. If you heard me talk about those earlier on the each end of the scale. So a pH neutral sounds great, and in some cases it is and can be. Neutral cleaners would also seem to be the ideal solution. However, there's several factors that affect that. The cleaning agent of pH range of 7, even though it is still 7, it could still interact with these metals, epoxies, coatings, and they are going to lack in a little bit of cleaning power. So a microalkalinity cleaning agent would be the desirable way to go, especially to remove the latest generation in flux residues that we have to deal with today. Bath behavior, it's basically defined by how a cleaning agent behaves in the bath. Some of the considerations that you need to take are exhaust, flux absorption, concentration fluctuations over time. If you look at the chart, as flux loads in the bath, there's will be a drop in pH, and it's going to affect the bath life. So if you look at the chart, the pH 7 chemistry falls off rather quick versus a mild alkaline that lasts a little bit longer. Too much flux loading also affects concentration measurements, and if you ever see foam in your bath, that's probably typically due to it going to the acidic side. The higher the alkalinity, the more the flux can be absorbed, and once the wash bath reaches a certain flux load percentage, the pH shift toward the acidic range happens. When this happens, it's going to have the attack on a sensitive metal is going to be far less frequent with a balanced chemistry versus just a pH only. So here's another prime example of chemistries. If we start out with the red arrow and we look at this pH of 7 at 4% bath loading versus the yellow, even at the 9% with these engineered chemistries, the yellow one absolutely holds on for a lot longer time at 4%. And what's amazing, if you really go up to the top blue line and look where we started about 10.5, even after 4% bath loading, it's still above 10. So it's ensuring that it's stabilizing that bath. And even as the flux increases, the mild alkalinity by far is the way to go. So cleaning agents are all about balance. So they must clean, they must not attack material, hardware, they need to be safe to the environment. They need to have long life, low consumption, good rinsing, and need to be repeatable. So in conclusion, pH shift happens when acidic fluxes can't be stabilized due to chemistries not having the right materials and or buffering agents formulated to hold these fluxes. So the higher the alkaline, the more the flux they're going to be able to hold, and the lower, the less flux they're going to be able to hold. It's going to give you shorter bath times. So when this acid is introduced to a pH neutral chemistry, bath life cleanability is greatly reduced versus a pH mild alkaline. The pH mild alkaline just seems to hold the flux residues a lot longer while stabilizing the bath, and it's still able to achieve the cleanability. pH neutral is also going to act a little bit different during qualification than production, so it's always a good practice to when you're doing qualification on a new chemistry, it absolutely is going to be different on a fresh bath versus a bath that's 30 days old. So it's a good idea probably to find out what the best optimal solution is for bath loading to do qualification. You don't want to get down the road and it goes south on you when you planned on it cleaning the same from the beginning. Soil loading, temperature, exposures, times, mechanical energies, all these cleaning agents, they all react together within the wash process. So a balanced chemistry will deem the best results. Cleaning is a dynamic process. You can't really study one single facet of this. The pH of a cleaning agent affects the entire cleaning process. It's going to affect it negatively and positively. So establishing a reliable cleaning process requires a better understanding of these factors that define the right balance to meet the product needs. But once again, you need to keep in mind that it impacts the environment, and we're trying to create a user-friendly process as well. So just real quick, if you think about, you're all familiar with eggnog. Eggnog pH is around 7. Alcohol is around 2 to 3. So if you start adding alcohol to pH neutral eggnog, it's okay as long as it's balanced correctly. But if you start getting too much acidics bringing into those neutrals, what usually happens is the eggnog is going to curdle. And I say that's pretty nasty. But if you think about that in the electronics point of view, you have a bath and you start out at the pH of 7, you start the flux loading. And as the flux starts to load, the bath starts to go away, and it basically does the same thing. It starts dirtying up, starts curling up and get nasty at the time to do maintenance. So it's just kind of a little comparison to compare the two together. So with that, I'll turn it back over to Cassie, and thank you.
Thanks, Jody. If you'd like to discuss this topic further, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we'll have someone schedule a follow-up with you as soon as possible. Again, we thank you all for taking time to join us today, and we hope to see you again soon. Stay safe, stay healthy, and have a wonderful day.